Hello, my name is Cagri Gungor. I am a PhD student at the University of Pittsburgh. I will present our research. Complementary cues from audio help combat noise in weakly-supervised object detection, conducted jointly with my advisor Dr. Adriana Kovashka. In fully supervised object detection, bounding box annotations are used for supervision. To reduce this expensive supervision, object labels are used in weakly-supervised detection. However, object labels are still expensive. This research uses captions of the images to extract labels because captions are more natural and can be found freely on the social media. But there is downside of using captions. Extracted labels can be different than ground truth labels, as you can see in the example. One of our motivations is to use audio to combat noise in these labels. Our other motivation is inspired by human perception. In addition to their eyes, humans utilize audio of the object during detecting these objects. For example, while we walk in the street, if any object makes a car sound, we detect the car easier than non-sounding objects. Our research is related to sound source localization, but they aim to localize sounding objects and they treat visual and audio as equally important modalities. Our approach can detect sounding and non-sounding objects with audio as an auxiliary modality. Our visual detection module detects and classifies objects with weakly-supervised training using only the object labels as a supervision. We have also audio module that classify objects similar to the visual module, used only for comparison. We define instance discrimination module, which has a contrastive loss between audio and visual. This module finds which visual region is related to which sound region. We train the visual, audio and contrastive loss in an end-to-end manner. We define an indirect path to utilize sound during inference. The audio-visual region similarity matrix is multiplied by visual scores matrix to obtain this indirect path. We also define an attention path to identify important visual region based on audio cues. The aggregated visual similarity matrix is element-wisely multiplied with visual scores to obtain attention path scores. We first train the audio-visual model with noisy labels, then we use the model to make prediction on the training datasets to generate new ground truth labels. These labels performs better than noisy labels in all the settings. The visual-only method is trained only with visual loss, while visual-only contrastive method trained with all losses. Visual-only contrastive performs better than visual-only method because contrastive loss improves representation learning. After using our indirect and attention path methods during inference, results are better than contrastive models. We compare our attention path results with other detection research on the AudioSet dataset. Our method performs better than other methods and reach the state-of-art result. We also compared our result with sound localization papers. We observed that our sound localization module performed better than several other papers. In this result, we show that the attention path improves the confidence of predictions. Thanks for listening.